In this session, we'll discuss about composite curves. So composite curves are nothing but you can join multiple curves or sketches and you can treat that as a single curve like the sweep or maybe the loft. You can use those curves as a single guide or trajectory. So let me show you this through example. So start a part file and then you move to the sketch and maybe in top plane I am going to define my first spline and I will go to escape and I will exit it. Again I will go for a second sketch and I will select this and maybe another arc I am going to create here. So these are two different separate curves which you can see. Just I will delete this and I will make it specific. So this part I will be deleting. So this is the sketch number 1, or you can rename it, or what you can do is just you go to F2 and you can rename it. This is the curve 1 and again I am going for another sketch and I am creating the curve here. Maybe this is the curve, another curve which we have. So two different curves we have. You can go for sketch, you can select a plane here, maybe the top, and you can define another curve, right click, select, exit sketch. So this I am going for curve 2. So this is the curve 1 and this is the curve 2 which I need to make it composite. So you can go to the composite curve and you can select number 1 and number 2 and go for OK. Then they will now behave as a single curve and you can see the color, and this you can directly use it. You can go to sketch, you can select this particular curve, or you can define a point also, 3D sketch, and again you can create multiple curves and you can join it. Next we'll move to the other options which you can see here, the XYZ point. So you can get curve through XYZ point and you can create. So for understanding this, we'll be opening the exercise file. So if you go to the edit, here you will get this XYZ different coordinate. So here you can see curve through XYZ, you can define the point and you can create it. So first point is 0, second point is 10, 10 and G is 5, 20, 30, 70, this will be 25, this is 35, this is 55, and this directions will be 15, 20, and this is again 30, and you can go to OK and you can see you can create the curves. just like that. This is the curve which you have created, and you can go to it and you can see the dimensions, whatever the XYZ coordinate you have, that you can directly create. So this is the XYZ which you can directly create. And you can also create a curve by using the reference points. So this is basically the through reference point which you can find here. So these are the curve through reference point. Over the object you can refer the points and you can create it. So for understanding this, we can take this example where you can refer the vertices, this one. So you can refer the existing vertices, and you can go for OK. You can close the curve also. That curve will be closed. So in this way you can refer the existing vertices and you can create and you can form. Next we'll look into the helix. So like that you can refer and you can form the resulting curves like the one is shown. So let us define the helical and spiral curve. The helical with r, theta and h, and spiral with a radial vector and number of turns. So how to create the helix and spiral, that I will show you. And then you can control the pitch and the revolution. Just like that you can have the taper, you can have the spiral curve in the same plane. So let us start with this particular concept. So here you can delete this and get the basic sketch which you have formed it. So how to create these sorts of figure. So I'll just start from scratch and I'll show you how to create from scratch. So when you go to the helix, so first of all you have to select a plane where you are going to position the sketch. So when you select the plane, you can define whatever the spiral parameter you have. So you dimension it, whatever the parameter you have given, 10 here, and then you exit it. Once you exit it, here you can see the constant pitch. What about the pitch? I am going for 15, or maybe I am going for 5. And what about the revolution, that you can give it here. I am going for 7. So this is the revolution. This is the base dimension which I have given. You can also go for the variable pitch, where you can have the pitch graph with the starting pitch and maybe 8, and revolution, height, and the dia maybe 8, that you can control for this variable pitch. And start angle also you can give. This is the start angle. When at 0, you can see this is here. You can have at 90. So like this you can go for the clockwise or counterclockwise control. You can reverse the direction. And let us come to the variable pitch and go to OK. So in this way you can generate the helix profile. Right click and go to edit, and here you can also see inside the constant the reverse direction and clock or counterclockwise. And also you can go for the taper and you can give the taper angle. Pitch I am increasing maybe to 10. You can see this. You can flip, reverse the direction, and you can get the helical path, pitch and revolution, height and revolution, all this alteration. Height I require 100, or maybe height and pitch, height with whatever the pitch values we are looking for, that may be constant and variable. So this all the combinations you can control, and you can go to the spiral parameter where you can create the 2D spiral curves. What about the pitch? You can go for 0.5, and the revolution I am going for 10, and start angle I am going for 0, clockwise or counterclockwise. So these are all controls you can give it. You can check it what maximum values it can take. So that purely depends on your parameter, the revolution. If you go for 3, here what maximum value it can take, you can check it. It is going for more. That purely depends on your number of revolution. So this you can update it. So what maximum value it is taking for this, 1.5 or 6. So this you can update it. You can go to more revolution, and you will get the final output. So in this way you can have the different sorts of output like this. So once you create your profile, you can directly go to sketch, and you can position with respect to this. The plane I will be selecting maybe this plane, and I will be placing the sketch here. And I will be exiting it. And now you can directly go to the sweep, and you can select the sketch, and this you can update. So it is intersecting. So what I have to do is I have to edit the dimension to 0.1, so smoothly it can go. So sweep, profile, and the path you can update it. Is not aligned properly. So what you need to do is just you go for Control C, and here you Control V, so that this will be aligned with respect to this. Now you can move and place it here, and now you can try with this, and this is the path, and update this. So you need to be very careful while creating this, whether this is aligned properly or not, otherwise this cannot be done. Just like that you can create your spiral path and all combinations. So extruding a 3D sketch, that I will show you here. So for understanding that particular concept, we will be taking this as our reference, and here I will delete the feature, and this you can see 3D sketch. And when you go for the extrude, and whatever the directions you will give, the direction of the extrusion must be specified for 3D sketch. So you can see here the direction vector is required when you specify, or you can go for this particular surface or face or plane, that also you can specify. So here you have the sketch, and that you have to. Now this is very important to specify the direction. So what you have to do is you have to select the reference that is parallel to this top plane, so that the direction will be updated, and you can extrude this. Now the point is how you can create the 3D sketch by using the combine or project over the face. Anyway, you can create the 3D sketch, and then you can also extrude that 3D sketch. Next very important feature is the draft feature, which directly you can apply by using different methods, the neutral plane, parting line, or step draft, and you can specify your draft angle and the neutral plane and the face to draft, and you can update this. So for understanding this, I will take a very simple example. This one, the face to be selected at the neutral plane and the face which you want to draft. So for understanding this, from our exercise folder, we will be opening this example, and when you go to draft, here you can see the couple of options which you have to understand here, the manual and the draft expert. If you go to the manual, here you have 3 methods, and the neutral plane I have to select, and the face to draft I have to also select. So what about the draft angle? That you can update and see it here. This is the final output, and you can update. So let me remove one particular surface and see the preview. So this particular face is not under the draft, but rest of all the 3 surfaces has been updated with the draft. So next we will move to the draft by using other controls. So you can see the pulling direction and the parting line to be selected. The pulling direction to be selected is this, and the parting line is this. So based on that, you can have this as your resulting output. So for understanding this, we will be opening the exercise file where we can understand this. So you can see this is the draft. When you delete this, you can see this is the parted line, which already we have discussed how to create the split line. So if this is the case and you are going for the draft, and here you can see the parting line and pull direction is this, and the parting line I am going for this. And now what about the resulting output that you can see? Maybe 5 degrees. So this is the control which you can see, the parting line. You can convert this. So these all controls you can see here, phase propagation along the tangent if you have. So here you don't have the tangent, so you cannot apply. If you have a tangential phase, then you can control this by applying this. Next I will show you the final option which you can get within the draft, how to split this. If you edit this, you can see the parting lines are this particular line which you can see here. This is all the entities of the sketch to be selected, and the face which you are selecting for the pulling direction is the base, and based on that you will be able to control in this way the tapered steps or perpendicular steps that you can control. So let me show you this from scratch. So if you go to the draft and switch the option to step draft, here you can see the tapered steps and perpendicular steps. So pulling direction, I will be showing this face, and parting lines are only these faces. So whatever the draft you will specify, based on that you will get this output. And if you go to the perpendicular, then this will be controlled like this, and you can have more degrees. And now update this to tapered. You can see now update this to perpendicular. Now you can get the perpendicular output, but in case of your tapered, you can see this is also controlled through the tapered, and in case of perpendicular, as you can see, this is perpendicularly maintained, but truncated you can see in case of your tapered. So these all controls you can directly get during this splitted draft option, which you can use. And also you can control the reverse direction you can reverse, and you can directly do the draft analysis by using the draft expert option, and you can also control the couple of other scenario like the inner face or the outer face. So what happens is, in case of your draft, and when you are going to draft expert, you can have the particular face analysis. Here you can see the neutral plane, and this is basically face to draft, which you can apply. Based on that scenario, you can see 1 degree, 0.5 to 0 degree and negative draft areas will be highlighted with this color, and with this color, and with this color if it is there, that you can find here, and you can apply to that particular sketch. So in this way we can use the draft, and you can apply the draft option, and you can do the peripheral control. So in our coming session, I will be discussing about the projects which will be understanding based on the concept which we learned. Thank you.